All right. Well, again, ladies and gentlemen, we are going to start into solving by substitution. So yesterday we talked about graphing, and you were able to graph those, but realistically, it's not terribly convenient to graph a bunch of things. Now that you're online, it's not too bad, but we'll need to figure out some ways to do this with algebra, just so we can do it with just pencil and paper and not have to graph every single time that we need to find the intersection of these two lines. So one of the two ways we can do that is by substitution, and then tomorrow we'll talk about elimination. So with substitution, uh, we have four plans. First, we need to solve or isolate a variable. So we need to get a variable X or Y, or maybe they'll use different variables, but we'll need to get one of those two variables all by itself so that we can then substitute what it's equal to into that equation. So then part two is to do that, substitute the resulting equation from step one into the other equation for that variable. So we're going to take the what x equals this chunk, we're going to take that chunk and plug it in for the x in the other one, which should eliminate all of the x's, and you'll be left with all y's, or vice versa, right? And then if you solve for what's left, you should get an answer for that. And we need both the x and the y for systems, so make sure that you plug that back in to find the other variable when you're done. So it looks something like this. Step one says we need to isolate the variable. Well, in this case, if you look here, where's my colors? You look here in red, our variable y is all by itself, which is great. So that's already isolated. So step one is done. We isolated a variable. It's all y is equal to that whole chunk. So what we can do is we can take this stuff that's equal to y. We can take those and we can plug it into the y in this equation, in the other equation. We can say, hey, you there, got to plug you in. Okay, so we're going to take all that stuff and we're going to plug it in for the y, because if y is equal to that y, you can replace them. They're equal to each other, so we're not breaking any math rules. Those two things are the same because they're equal to each other, which means we can plug it in. So if I plug in this bottom section now, it'll look something like this. It'll say 7x plus 3. That all was the same, but now instead of y, I need to replace that y with, well, negative 5x plus 30. Now make sure you plug it in with parentheses. Anytime you substitute a variable with something different, you should be replacing it in parentheses, because it's all that. Because if you drop that, you won't remember to multiply the 3 into both of those. You won't distribute well and you'll make some mistakes. But then the rest of that equation is as it was, so equals 42. So red is the only thing I changed. I replaced that whole y with that red part from the first equation on the top. Cool. So now we need to distribute and solve these. Remember, to solve, we distribute, we combine like terms, we get the variables to the same side, which they should be already, and then we solve a two-step. So we'll distribute this 3 in. 7x minus 15x plus 90. 42. Great. We'll combine like terms. That and that, negative, or 7 minus 15. What is that? That's a negative 8, I believe. Plus 90 is equal to 42. And now to solve a two-step equation, we will get the x part by itself, so we'll subtract 90. 42 minus 90 is what? 48, negative 48. Okay, so subtract that over. 42 minus, don't forget your negative. And then if we finally do our last step and divide by negative 8. X is then equal to, well, that's a positive 6. Great. So we just found our x value. Found our x value. We plugged it in. We solved for x. Now we're not done, though. You need to make sure that you solve for y. Okay. You have to go back and get the y. If you don't, you have only found part of my problem. Remember, every answer is an x, y. This is what we're looking for. Until we have that x, y, we are not done. So we need to go do that. We'll take this 6. And the easiest place it'll probably be to plug it in is where you solved for the y, because it's already solved. So then we'll just have to do the right side, and it'll already be equal to y. So that's great. So we'll plug it in here. Almost always the easiest spot to plug that in, if I do so. Plug it in once again. Make sure you replace with parentheses so that x is replaced with parentheses 6, and we solve. Y equals 0. Great. But do me a favor and don't leave it like this, because this isn't really the solution. This is an x value and a y value. The solution is the point. So if you don't write it as the point, you're not really solving the problem, right? You need the point so that we remember it's actually where these two things intersect on my x-axis, right? It's where these two things, or not x-axis, but on my graph, where they intersect. So the answer here is x value 6, y value 0. Done. That is substitution. That is substitution at its core. This one was solved already for y, so we'll look at a couple other ones. But overall, that is the general plan here. Okay. So this is the most straightforward example where we don't have to do anything beforehand. Okay. So sometimes, however, we do need to do some stuff beforehand. So let's look at an example that isn't already solved for us, maybe a little less convenient one. Okay, so in this one, we look at this and we say, hey, we're not solved for a variable yet, right? We're not solved for a variable, but it's really important that you take some time to decide what's the easiest way to go about this. So you want to go in and say, hey, what variable in which equation is easiest? It doesn't matter which of the two equations you use. It doesn't matter whether you use x or y. Either way, you'll do the same thing. So make it easy on yourself, right? If you tried to solve that top equation for y, like it was the first time, your x would end up having 1/7. You'll trust me. You'd subtract over x, and then you divide by -7 with that y, and you'd get negative or positive 1/7 y, which or 1/7 x, which isn't very good. We don't really want that. So instead, you'll notice that this x right here, he's kind of all by himself. He doesn't have anything to divide by after. The only issue is that he's next to -7y, but I can deal with that. If I add 7y to both sides in this equation, right, if I added this over, whoops, you would get an equation like this. I'll just write it underneath. It'll say x equals 7y plus 53. And that's great because now my x is solved for, right? So now I don't even have to worry about this equation anymore. That's all gone. I added that to both sides, and now that's gone. And now I have this new equation that's solved for x and ready to substitute, because I can take this stuff and I can plug it into the x right above it. We can plug it right into there and say, hey, if that's x, so is that, and we can replace that. So we'll go do this. If I replace that in there, once again, make sure you use the parentheses. Parentheses 7y plus 53 minus 5y 18. Great. Okay. So you may get some bigger numbers because you are going to multiply some stuff together, but that's okay. So if we do this, distribute in your -4. -4 times 7 is -28y minus 4 times -50. 4 times 50 is 200. And so 212. Like I said, you might get some big numbers, and that's okay. They will divide out nicely, hopefully. So that'll be good. So, but this is why we need substitution, right? If you tried to graph something that had like negative 28y minus 212, you might get some pretty nasty numbers, or it started with 19. So that's why we can't just graph everything, because the equation x minus 7y equals 53 is kind of a big one, right? So it's nice to not have to graph all these. All right, so if we keep going, we'll combine our like terms. Negative 33y minus 212 19. And if I add 12 to both sides, or add 212, well, that is 2031 to 31. Right. Okay. So then I need to do that, and I don't know that off the top of my head. What is 231? 231 divided by 33 is 7. So if you finish this out, so y equals negative 7. It'll be fair to use your calculator to divide that out. So y equals negative 7, which is great, but that's not our final answer. Once again, we need to plug that back in to find a good value. Usually the easiest place to plug it back in is originally where you solved for the first variable, because it already says x equals, so then I won't have to do much once I plug it in. It's kind of nice. It says then that's, let's do x equals 7 times negative 7 plus 53. So if I multiply that out, x equals negative 49, or negative 49 plus 53 is a positive 4. So my final answer here, if I bring these two together, is 4, negative 7. 4, negative 7. So make sure you plug it back in and get both values. Cool. Nice. All right, so that was a little harder, right? We had to solve for our variable first. Make sure you're intelligent about how you solved for it. If you picked any other variable in either of the two equations, I think you would have run into some fractions. If you run into fractions, not the end of the world. You can still do it. Just be more careful. And if you do run into fractions, you can multiply. Once you've substituted in, you can multiply by the greatest common denominator, so that you can get those fractions out of there. Okay? But we'll do two more examples quick. There are two other things that can happen. One of which is actually the easiest type. It looks like this. It says y equals negative 7x minus 1, and it says y equals x minus 9. So those two things are both equal to y, right? Well, the good news is, if we're using substitution says we need to isolate a variable. Y is isolated for actually both of these. But let's just say this one. Specifically, we'll say it's isolated to that, which means we can take what it's equal to, and we can plug it in for the y in the other equation. But what's that going to look like? Because if I do that, look at that. Hey, if I plug that in there, that's the only thing on that side, which means if I plug negative 7x minus 1 in there, well, negative 7x minus 1 is equal to, well, the other side, x equals negative 9, or x minus 9. Great, and sure, you can put parentheses in here. I made it a big deal, right? But when y is the only thing on that side, we actually don't really need those, because there's nothing going on over there. So I won't write them for this one. Normally, you'd make sure you write it in parentheses, but in this case, since nothing else is over there, that's all there's there. Great. So this one actually ends up being easier. This is one of the easiest substitution problems that we have because it's already set equal to y. So if they're both already solved for this, sure, we could graph them, but it's also pretty easy to use substitution on problems like these because they're pretty much set up to set them equal to each other and solve it out. So if I do so, I can get these on either side. I like to move my variables left. It's just my habit. If you don't care, you don't have a preference, move them right. Sure, if you get positive numbers, that's good too. So if I subtract this, I have negative 8x minus 1 is equal to negative 9. And solve our two-step equation. Plus 1 negative 8x is equal to negative 9 plus 1 is negative 8. Great. And if I divide by negative 8, x is equal to a positive 1. Great. And you can once again substitute it into either equation because it has to work for both. So if it works for one, it will work for the other here in this case. So we'll plug 1 in here. Why not? That one looks easier. 1 minus 9. Well, means y equals negative 8. So this is one of the easier ones because they're already set up to be substituted easily. One negative 8. That's my final answer. Awesome, awesome, awesome. Okay, so yeah, a lot of people don't use substitution for problems like these for some reason because they look a little different than they're used to with substitution. But I think they're the easiest ones to use substitution for because they're already just kind of set up to be equal to each other, which makes sense, right? Because we're looking for when these two things are equal to each other, whereas solution for both of my two things. So if y is equal to both, well, when are those two things the same? When are they equal to each other? And that's kind of what we're doing here. So that works great. Okay, cool. So then the last one, just in case you see something weird happen here, let's check out one of the weird ones. So you might see something like this. You might see something like this. Once again, make sure you're intelligent about what you're solving for. You're always welcome to solve for any variable in any equation, and it should work out. However, if you're smart about it, you should make sure that you pick the easy ones to do. So like if you look for the top equation, x isn't that close to being by itself, and dividing by 6 will lead us with some not terribly nice numbers. On the bottom, you could do it, but solving for x to give you some fractions. It's kind of 2 steps for the y. I think the easiest one is to solve the top for y because it's only 1 step away, right? We just need to divide a 2 on both sides. So we'll get this y by itself. So y equals 6. Whoops, 6 divided by 2 is 3x plus 5. Great. Okay. So now this equation's out of here. We don't have to worry about that anymore. Once we got it to where we want it, now we know a better version of our equation, a more useful version. So I'll take this and I'll say, well, take this stuff and plug it in for the y there. We need that whole side plugged in for the y because it says y equals 3x plus 5. Cool. X minus. The minus sign's still there, but it is not inside. It's not attached to that y, right? It's almost like a negative 1 out here. So you can even think of a negative 1. I don't tend to write my negative 1s, but that's kind of what you're thinking about, right? So that negative 1 is out front of parentheses. Don't forget parentheses 3x. Once again, make sure you are plugging in with parentheses. All right, so then we'll distribute. That's kind of like that negative 1 once again. So we'll distribute in 3x minus 3x minus 5. 5. But wait a minute. If I go combine like terms, which is my next step, 3x minus 3x, that's gone. You could write 0, right? But we don't really write zeros in the middle of equations because they don't do anything. So I just get negative 5 is equal to 5. Is that true? No. Negative 5 isn't equal to 5. 5 is equal to 5. Sure, that would be true. But negative 5 does not equal 5. This is not a true statement, which means there is no solution. And that'd be true for anything. It's not just because one's a positive 5 and one's a negative 5, right? If you got down to this and it said 2 is equal to 7, that's not true. No solution. Okay. Anything that where your variables drop out and you're left with a false statement, it's not true. That is a situation where you would say no solution. Okay, so the problem here would be some no solution, which means we probably have, not probably, we do. These are parallel lines. If you graphed these, I'm not exactly sure where they cross my y-intercept, but they'd look something like this. Right? These would be parallel lines where they would never touch each other. So there is no solution. There's no intersection point because they never touch each other. Right? Okay. And then I didn't do a whole example of this, but if you did all this work, and you got something that said 10 equals 10, or -4 equals -4, or 0 equals 0. If you got any of those when all of those variables disappear, that is infinite solutions. You would write infinite. Ooh, what are you doing? Writing a little too fast, apparently. You would write infinite solutions for those. And that would be two lines that are right on top of each other. We talked about that yesterday when we were kind of talking about what systems are and how we solve them. Those would be graphed right on top of each other, which means all of the points in one work, which, all lines are an infinite number of solutions to the same equation, x and y. So you may get a no solution or an infinite solution out of these problems. Okay, so that is kind of one of the unique things that might happen. It might happen to you, so be prepared for that. Otherwise, that's the plan. Get any variable by itself, get it isolated, get it alone on its side, take the chunk that it's equal to and replace it for the same variable in the other equation, solve for x or y, take x or y, plug it back in, get your other one, and write it as an x, y point. That is the plan for substitution. Let me know what questions you have when you have them.